Hi, I'm Brian, and I'm going to show you the code for our first GUI. So, at the very beginning of the script, we open the campus map and set it on the axes of the GUI. And then we check if the data structure where we're storing our data exists in the workspace. And if it doesn't exist yet, then we create it. Once the data has been collected, we check the location index and the time that was input by the user to determine exactly in which structure and which field we'll store the data. So for the next part of our code, we have the store button, which saves the time and the date that the user inputs into the GUI. After they finish typing in the information, they push this button, and then we use the get command to get the values, and then we check what time of day it is by setting time intervals that correspond to morning, noon, and evening. And then once we determine what time of day it is, we send it back to the workspace by saving it. The next section in our script is the location button, which when selected lets the user click on the campus map to select the location that they are currently at, and this way the code can know what the index for the location is, and the index is important because it corresponds to a certain structure in our structure array where the data will be stored. So here we have a series of if and else if statements, and each little block corresponds to a location. You can see here that we have the coordinate range for each location. That's because on the map we have regions that correspond to each data site. And so we made an if statement for each place so that when the region is clicked, that location is selected. And then at the end, the name of the location and the index of the location is saved to the workspace. And the last part of our GUI 1 script is the open circuit callback button. And what it does is it starts the data collection for the open circuit voltage sweep. So first we call in our data structure again, that should be in the workspace. You can see the for loop loops 3 times, once for each trial. We open the figure, then we start plotting the data so we can see that it's functioning properly. Then we check the time of day and the location so that we know exactly where to store it in the structure. Here we have some custom trial completion messages, and then once all the trials complete, we save the data into our structure and send it back to the workspace.
Hi, this is Megan Simone, and I'm from Team Airheads, and I'm going to show you how to use our GUI. Okay, when we run our GUI, the GUI will pop up, and first it allows the user to select a location using this push button, and then you can select your location. So we are at Hoagland Hall right now, so when you just click on Hoagland Hall, it'll show up Hoagland. And then it allows the user to input time in a 24-hour clock system. It's 11:43 right now, and it is June 6, 2013. Then you press this button to store the time and date. And then we begin our load sweep. And then the load sweep sweeps the variable resistor 0 from resistance code 0 to 255 while keeping variable resistor 1 at resistance code of 128. And this records the voltage at each resistance code. And we do 3 trials for each method. So right now it is doing this load sweep trial 1, and once it hits 256, you can press enter and it'll start the next trial. So we just finished the 3rd trial of the load sweep method, and now we're going to go on to the open circuit voltage sweep, which is this button down here, but first we have to take off the open circuit jumper, which is this little piece right here. And then we begin our trials again. Which will happen. Okay, now that we are done with our 3rd trial of the open voltage sweep, we can press enter one more time, and then we can go into our workspace, and here a solar data structure is stored, and we can go and look and make sure that all of our data is in fact in our structure.
Hi, I'm Sabrina for Team Airheads, and I'm going to show you how the second GUI works. We bring in the campus map again and have it display, and then we also bring in all of the data from the GUI 1. And so when we do that, we load the morning data, or this is the evening data, and then we find the average of all of the evening data and assign that to a vector called ELA, and it's going to be at the right index. So whatever index from the first GUI is the same in the second, so we know which data corresponds to which one. So we do the evening, and then we do the morning and the noon data, and we calculate all the averages for all of those for each location. And then underneath each location, we also convert the load sweep trials to power. And we do that using the max function in these for loops and assign them to variables called evening power, morning power, and noon power, and then also average power. And we do that for all 18. In the code, the second plot or drop-down menu has the tag plot method, and so we get the value of that and assign it to the workspace as plot type so that we can access it later. And the first drop-down menu has the tag time, and we also get the value for that and assign it to the workspace. So when the user clicks the big go push button, we bring in all of the vectors and variables that we had assigned to the workspace so that we can use them within this function. So we bring back in the type and the plot type and all of the powers and averages. And then we enter a big if-else-if statement. So for example, the first possibility is if the first drop-down menu, you pick the first one, and the second drop-down menu also pick the first one, which would correspond to morning and max power. So if we enter this for loop, we have the x and the y vectors, which are the pixel numbers of the different locations that we have. And then this bit right here creates the mesh grid and interpolates the data. And we have to scale the data so that it is between 0 and 255. So we do that here using the min, the max functions, and then rescaling it in this line. And then we use the contour function to plot the contour lines. So we have these else if statements for all 8 different options. So let's try to run this. And here's the GUI that pops up, and say that I wanted to see the noon open circuit voltage data. So I hit plot data, and it comes up as these pretty contour lines. And then I can hit the clear button, and it goes away. And I can try a different kind. Let's see, average, max power. And it plots it.